I've got the equation z equals negative x squared plus y squared on the board. This is going to give us our last quadric surface. Now, again, I've given us a nice case where this one is centered at the origin. So if I take a look in the xz plane, which would mean y equals 0, so that just kills off that term, I'm getting z equals negative x squared. And as we discussed, that's just going to be a parabola that opens down. If I take a look in the xy plane, which has as its equation, the yz plane, which has as its equation x equals 0, I'm going to get z equals y squared. Now that's a parabola that opens up. If I were to take a look in the xy plane, that would be z equals 0. I can see what I would get is a degenerate hyperbola, because I'd have negative x squared plus y squared equals 0. That's just going to give me intersecting lines. This particular shape is the one that sort of breaks all of the guidelines that I've established so far. So I'm going to have parabolas. In any plane that's parallel to the xy plane, I'm going to have some sort of a hyperbola. In the xy plane itself, I get a degenerate hyperbola. And ordinarily I've said, draw the oddball one, which would be the hyperbola in the middle. Here, I'm going to draw it last. And even though I get something kind of interesting in the xy plane, I'm not going to draw that. I'm going to move to parallel planes. Let me just show you why. If I were to draw these two traces first, which is what I'm going to do when I have parabolas that open in opposite directions, I will go ahead and start in the yz plane. I like to do that when I can. Now, if I draw my parabola in the xz plane, this is the front part, this is the back part. So I know I'm going to draw my x-axis ultimately so that it's coming down and to the left. Okay. So the leftmost part is the front, the right part is actually the back. And you'll notice I didn't come down to what looks like the same height. I'm setting it up so that I'm going to make my x-axis parallel to the line determined by my marker right here. So I purposely made the front look like it's lower down, just like on the x-axis, the front part looks like it's lower down than the back half. So I've got that. Now, the xy plane would be right here in the middle where these guys meet. That's not going to be helpful, because then I would have these spider legs. We don't like to have these curves hanging out, not connected and attached to other stuff, because if we do that, it looks like we've got a bunch of curves rather than an actual surface. So I'm much more concerned with what happens up here and what happens down here than I am with what happens in the middle. So when I've got parabolas that point in opposite directions, I'm always going to, for the hyperbolic cross sections, move to parallel planes rather than what's in the center. And I'm going to have to do two separate ones, because I'm not going to get the same thing if I plug in a positive number and a negative number, because I'm not squaring the z. So let's take a look in two planes, z equals 1 and z equals negative 1. Now both of these are parallel to the xy plane. Z equals 1 is above it, and z equals negative 1 is below it. Now if z is equal to 1, I'm going to get 1 equals negative x squared plus y squared. And if z is equal to negative 1, I'm going to get negative 1 equals negative x squared plus y squared. To get that into a standard form, I would multiply through by negative 1, and that makes it x squared minus y squared. This one, if I chose to write the positive term first, is y squared minus x squared. So I'm getting hyperbolas in both planes, but they're going to have different branches. They're going to be different types. Because here, y can't be 0. But y equals 0 would be the x-axis. So this hyperbola is going to have a top branch and a bottom branch. Now, both of these I could write as over 1. So, from the center, I could come up 1 and down 1, and that gives me my vertices. If I go left and right 1, I can draw in this little box whose diagonals are going to be the asymptotes, and then I can draw in a top and a bottom branch. Notice in the plane z equals negative 1, it's x that can't be 0. But x equaling 0 would be the y-axis. This one's going to have a left and a right branch instead of a top and a bottom branch. So, again, both of these are over 1. I can come 1 out in the x direction to get to my vertices. I can go 1 up and down so that I can draw in the box whose diagonals give me the asymptotes, and then I can draw in the left and the right branch. So I'm getting hyperbolas, but they open in different directions. Now what I'm going to do is I'm going to suppose that I've drawn this up to a height of 1, so that these points right here are in the plane z equals 1. Okay. Turns out those points are actually going to be the vertices right here of my hyperbola, because I can see this is going to have a y value of 1. But what would put me at z equals 1 would be y equaling plus or minus 1. This has a y value of negative 1. So these points right here are going to correspond to the vertices of this hyperbola. Now, I've got a branch where y is positive and y is negative. In the xy plane, I called that a top and bottom branch. In 3 space, the y-axis is horizontal, so we're going to have a left and a right branch instead. So I'm going to go ahead and draw in a left and a right branch for my hyperbola, making the vertex this point right here. Now, down here, I'm going to suppose that this is at a height of z equals negative 1, and these points right here are going to be the vertices of this hyperbola. Again, I can quickly confirm what would put me at z equals negative 1 is x equaling plus or minus 1, which are the x coordinates of these vertices. Okay, now here we've got one branch where x is positive and one where x is negative. In the xy plane, that's a left and a right branch. In 3 space, x being positive is forward and x being negative is backwards. So we're going to have a front branch and a back branch. And one thing that's really important here is that I am going to totally exaggerate the scale. So I'm not going to worry about drawing things exactly to scale. I'm going to make sure that my front branch and my back branch both have a clear left and right side. So I'm not going to draw it like so that the left and right sides are too close together. I'm going to, if necessary, exaggerate the width so that this is my front branch, that's the left side of the front branch, and that's the right side of the front branch. And I'm going to do the same thing for the back branch. I'm going to have this branch of a hyperbola that's opening backwards. I've made it very clear that there's a left side and a right side. That's because now I need to connect to all these things. Because right now I've just got a bunch of curves. I've got all these spider legs hanging out. These curves need to be connected so that I can see that I have a two-dimensional surface. So I'm going to connect like part to like part. I'm going to just label. Labeling isn't necessary, but you may find that it's helpful in figuring out what to connect. This was the left and the front. This was the right and the front. This was the right and the back. This was the left and the back. Now up here, these guys are on the top branch. This is left and front, and this is left and back. This is right front and right back. I'm going to connect like part to like part. So left front gets connected to left front. Left back gets connected to left back. Right front gets connected to right front. Right back gets connected to right back. Now it's starting to look like a two-dimensional surface rather than that just a bunch of curves hanging out and having a good time together. Okay. This shape is called the hyperbolic paraboloid. And informally, we refer to it as a saddle. Okay. Now, I could draw in my axes here. Like so. So this is the center point right here. What I actually kind of like to do on the saddle is I like to draw in the horse and the rider. This is not part of the math. This is just my artistic interpretation of the problem. So, we have a horse. That is a lovely horse indeed. Oh, let's give the horse a tail, shall we? We'll give it a pig's tail. Okay, so there's the horse. We can give it a face. Yay. Okay. Excellent. And then we can have the rider. We'll make it a lovely cowgirl atop the horse riding on that saddle. Now, obviously, drawing the horse and the cowgirl are not part of the math, but you should be able to draw this shape, and the key, again, is connecting the like part to like part. So with this shape, simply drawing the traces isn't enough. You then have to connect like parts of the top trace and the bottom trace in this case. In some cases, it could end up being the left trace and the right trace, or the front and the back, depending on the orientation of things. This completes our survey of quadric surfaces. Most of the examples I've done have been relatively nice. Most of them have been centered at the origin, and most of them have been oriented fairly nicely so that if there was an axis passing through the center, for most of them that was the z-axis. I purposely kept things relatively simple for two reasons. One, I wanted to just focus on the quadric surfaces, the skill of being able to draw them, recognizing their equations, etc., etc. Okay, so I chose some simple examples so that we could really just focus on the underlying concepts of things. Two, I wanted to leave some stuff for you to struggle with in the homework, and some of you will struggle with this. When you've got something where the center is on the y-axis instead of the z-axis, it's sometimes a little harder to draw. The x-axis tends to be the trickiest one for things to be centered on. Okay, so some of you will struggle with that. I'm more than happy to work with you in office hours, but I did purposely leave some of those issues for you to work with in the homework. Also, we didn't do any examples where we had to complete the square to figure out what the center was. That's an algebra skill you should be familiar with. If any of you need a refresher on completing the square, I'm more than happy to go over that. Want to let you know that issue will show up in the homework, so do be prepared to do that. And if you need a brush up on that, just let me know. I'll be happy to work with you.